These men are part of an investigation of movements deep in the earth. They're the advance team for an expedition of German earthquake researchers in the Atacama Desert in Chile. Using explosives, they're blasting holes into which they'll put highly sensitive measuring devices. Compared to the massive forces lurking beneath the surface, any disturbances up here are child's play.
Fuego!
The next day, the German scientists make their way to the site. They anchor 30 probes like this one, 500 meters apart, positioned exactly level. The earth below rumbles on, while 30 high-caliber ears listen.
Could you stand very still, please?
Everyone's quiet as the machine registers a quake.
There was one just now.
It's like tuning into earthquakes using Dolby surround sound from 30 different directions.
The instrument we've built in here works in principle like a microphone. We call it a geophone because it picks up waves produced by earthquakes, in the same way that a microphone picks up sound waves in the air. It just works in another frequency range.
The northern Chilean desert is an ideal location for this research. The next powerful earthquake here is expected soon, but when? This project is just a tiny part of the quest for accurate earthquake prediction. For other parts of the experiment, the scientists have to drive thousands of kilometers. That's because the earthquake area is enormous. The outer reaches are dotted with technical equipment, and it has to be kept running. That alone can be back-breaking work. There are 15 of these man-made caves which run on solar power. Günter Asch came up with the idea of measuring Earth movement this way. He knows the geology of the Andes as few others do. He's been doing research here for 30 years.
This instrument is capable of recording the tiniest earthquakes, far beneath what a human can perceive. And the other one is capable of recording the most violent, destructive ones without suffering damage itself. So with these two instruments together, we're in a position to cover the whole seismological spectrum.
Data are sent to Potsdam via satellite.
If we just wait 10 minutes, we'll have an earthquake on there.
Directly under him, 40 kilometers down, one tectonic plate is pushing beneath another. Asch can measure this process, called subduction, using 6 different parameters. Asch says everything is alive, including the desert. For him, earthquakes are the way the earth breathes.
We need earthquakes. Without them, there would be no life. The very thing that is catastrophic is at the same time the basic requirement for a biosphere.
The Chilean explosives expert makes his way to the next site, past abandoned mining settlements. Much of the world's raw material comes from northern Chile. Endless freight trains loaded with copper head to the coast, where the metal is transferred to ships.
The mine owners naturally want to know what they may have to deal with. The mine engineers, who are responsible for safety, already know the kinds of magnitudes they can expect in this region.
Copper is such an important element that an earthquake here sends shockwaves to the Chicago Commodities Exchange. The Atacama region is heavy metal country. This is the port city of Antofagasta. Computers and cell phones worldwide depend on copper and molybdenum exported from here. It's still not possible to predict earthquakes, but calculations can help. Cemeteries like this one would be relics of the past. Meanwhile, one of the German researchers meets with his Chilean colleagues to tell them about Günter Asche's new measuring station. Many of the team members studied in Berlin. There has been cooperation between the two groups for a long time. Bernd Schur demonstrates how they'll be able to pinpoint the signals coming from what's called the seismogenic zone. On the campus of the University of Antofagasta, earthquakes are a part of everyday life.
I experienced the one in the south last year. It was really strong.
Equipment is being packed for the cold desert nights. These men go without the comforts of a hotel for weeks at a time. That's the satellite phone. It can be crucial in an emergency. We head south to the European Southern Observatory. Here, the instruments used by the earthquake researchers have been coupled with split-second accuracy to the giant telescopes.
We measure the acceleration of the Earth's movements using the accelerometers. When the values exceed a certain threshold, the mirrors and all the instruments in the observatory shut down automatically. That has to happen within seconds or even faster to prevent damage to the mirrors.
Higher and deeper. As humans peer further into space, so too can they listen ever more clearly to what goes on deep in the Earth. The earthquake scientists' instruments may not be as grand as these telescopes, but in some ways they're just as impressive.